Okay, now we're going to go ahead and create the interpreter, which is going to take this growth code and it's going to make it into a geometric form. So basically, as we saw here, this is an example, basic example of an interpreter. So it takes these symbols and it's going to, in this case, it's going to move forward, it's going to turn left, turn right. And so I'll just scroll down to the basic pseudocode of our interpreter. So we're going to take in a growth string as well as a couple other things like angle and length. I'll just add those two things. It's going to output geometry. So what it's going to do, it's going to go through each character of that growth code and it's going to apply an action, moving forward, saving a position, or relocating the position, the last position, or rotating left or right. And it's going to basically store where it's been and save those as points and then use lines to draw them into a tree form. So here's our growth code, and so the component's going to look similar to this. We're basically going to have a loop that's going to apply if statements like this one to find out what to do for each of the characters. So let's go ahead and drop a C# component down, and I'm going to just right click and let's call this one this input here, growth, should be growth string. So let's call it growth string. And make sure you set the data type to string. And then let's create an input here for the angle. Let's be able to give it a length. And so the length will control how long the branches are, and we'll set the type to double. And then let's add another variable here that controls the rotation angle, and we'll call this rotation angle, and we'll set this to being a double as well, so these are decimal numbers. And let's go ahead and right click over the input, and then we'll call this L systems interp. Call this L systems interpreter, and let's drop down a couple. Let's drop down a couple sliders. The first one we will use for the length, and let's right click on it, and we'll set its minimum to 1 and maybe its max to 100, and then the current value can be at 1, and we'll plug that in for length. And let's go ahead and create another slider. Let's right click. Let's set its values to go from 0 to 180, because these are going to be degrees. And we can leave it on the current value of maybe 10. And we'll drop that into there. And let's go ahead and put the growth code into the growth string input. And I'll save. And let's go ahead and open up the code, the script editor. And so the first thing we're going to do is just create a series of variables to store the points along the path that we go, so that we can draw lines out of them. And we're also going to create a variable to store directions or vectors, and that's going to help us to be able to control how we move in three-dimensional space. It'll help us to rotate, basically. So the first thing we have to do is let's create a variable of type point3D, and we'll call it origin point, and that'll be the point that we start from. And let's just set it right now. I'll create the new point 3D, and I'll set it now to be at location 0, 0, 0. After that, what I want to do is actually convert the rotation angle that I'm bringing in from degrees to radians, because all the rotation commands in the Grasshopper application, in the Grasshopper libraries, they use radians, not angles. So I'll just do a quick equation to convert angles to radians. And so this can be looked up really anywhere on the internet. And I use, if I want to access pi, I can use math.pi, and that will tell the computer to use C#'s math library and to use the pi value that's under the pi property. So then I'll type 180 and I'll just put a 0, 0.0, just so that it knows that it's working with doubles here, or decimal numbers. Okay, so this should give us a conversion from radians to degrees, and I should make sure I spell rotation angle correct here. Rotation angle looks good. Okay. Now I'm going to define a variable to store the list of points along my path, and I can use this later to draw the lines that will create the branches of the trees. I'll call this R points, and I'll go ahead and create this list variable using this special syntax. Point 3D. Okay, so that's going to create a new array variable of type list, holding 3D points, called array points. Next, I need to create a variable that allows me to keep track of my current direction. So it's going to be a variable of type vector 3D. It's going to be called move vec, and I will create that vector here, and I'll set it equal. Initially, it'll be pointing in the z direction. And then I'm going to create an array of points, another array of points to save my position. It's going to be used to save the position when it comes across those brackets, and I'll call this PT stack, and I'll just create this new list variable as usual, and I'm going to be a little lazy here and just copy this down here, and I'm going to create a variable to save the direction that I'm facing when I get a character that is a square bracket and an open square bracket. I'll call this vstack, and this will save all the directions the way I was facing in my position when I hit that open square bracket. So vector 3D, there you go. And okay, so that's going to store my positions, my directions. The next thing I'm going to do is I'm going to need to create a variable to hold a character, because I'm going to go through, as before, I'm going to go through the, in this case, the growth string, character by character, and I'm going to apply my rules. So this rule char is going to be a temporary variable to save that character. Okay, so now I'm going to create one main loop where I go through it's going to go through all the characters in the growth string. So I'll use a for loop. And it's going to start at it's going to start at 0, and that loop's going to go as long as it's true that I is less than, in this case, the length of the growth string, and it's going to increment by 1. Okay, and before I fill in the loop, what I'm going to do is, so this loop is going to interpret the growth code. And then I'm going to have another, then what I'm going to do is, what I should have, well then what I'm going to do is, actually it's better form, what I forgot to do is I need to define a variable up here that's going to hold all the lines that I'm going to output. Because remember, I'm going to create lines in the end. Those lines are going to represent the branches, so I'll create a list variable. I'll call it line array, and this is going to hold all of my lines. Okay, so got line array in there. Anyway, so okay, now we come back. We have this loop that's going to interpret the code character by character, but then I'm going to need to create one final loop that's going to generate, the lines from the points. And so this is going to be a for loop. So what I'll do to save time is I'll just copy the for loop I've made here. So it's going to be a for loop that's going to start, in this case, I'm going to have it start at 1, and it's going to loop through the array of points. So we have this array of points starting, holding all the key positions that we went to, defining the tree geometry. So we're gonna go through the array of points. So it's going to loop through the array of points as long as it's true that I is less than the count, the number of points in the array of points. So if you use the dot operator and the special word count here, it will give you the number of points in this array. And so this loop will start at 1 and go all the way up until all the way up through all the points. So the thing I want to do that's a little different, instead of incrementing by 1, I'm actually going to increment by 2. So I'm going to go I is equal to I plus 2. So that means it's going to increment by 2. The reason why I'm doing this is because, the reason why I'm starting at 1 and incrementing by 2 is because I'm going to end up creating a line, and a line requires a start point and an end point. And so I'm going to get that start point and end point from this list of points. So you'll see how this works when I get to it, but it's a little slightly tricky to think about, but once you think about it a little bit, it should be pretty easy to get. So what this is going to do, and actually I could just, I'll probably just do it here. So what's going to happen is I'll have a line. I'm going to create a line when I'm inside this loop, and when you make a line, it needs a start point and an end point. So I'm going to grab a point out of the array of, I'm going to grab a start point here, and it's going to be at index number I minus 1. That's going to be the start point. And then let me just copy this to save some time, paste there, and then it's going to be, so the start point's going to be I minus 1, and the end point's going to be I. So basically the first time I go through this loop, it's going to create a line using the point at index 1 minus 1, which will be 0. So it'll grab the first point in the list, so it'll starting at 0. And then it's going to draw that line until this, basically the point that's at index number 1 during this first loop. So that would be the second point in the list. And so that's why there's this tricky thing where it's starting at 1 and incrementing by 2, because it's going through the list in a way that allows you to get basically a start and an end point each time. So once I create that line, I'm going to save that in that line array that I just defined above. And I use the dot operator with add, which is a special method which will allow me to save lines. So I add new line. And then the final step of this is I'm just going to output, the output is A, so I'll just output the line array. Okay, so that's the basic structure of the code, and now I just need to go in and I will I'll finish up, I'll write the code to interpret the growth code here and to save the points in the lines.